Hello, St. John the Evangelist School, sixth graders for the school year 2020 to 2021. This summer, I have a plan that I will release for each of my math classes three assignments, which will include a video and some problems to work out that are based on the video. And this is the first of those three. You're probably watching this, receiving this around early July. The second one I planned for mid-July, and the third one for early August. These assignments I'm trying to choose strategically so that they support us going forward and not just busy work. Although some of you may find the work easy, there will be some review aspects. Probably everything in this first assignment will be review, but maybe in the second or third I'll start to get into some new material to some degree. You should view it as an important part of your sixth grade math experience. So please take that approach. I decided that in this first video we would explore again decimals. It so happens that in the first chapter of the sixth grade math textbook, it's all about decimals and decimal operations to be able to add, subtract, multiply, divide any two decimals. And I know that I've said to you in the past that one of the big goals of fifth and sixth grade math is to be able to perform those four operations on any fraction, and decimals are fractions. They're special kinds of fractions. So let's just get started with a little bit of a review. I'm going to sort of present something to you and then tell you that you really don't have to be able to do this. This number here, of course, you would read 9,812,345.6789. It's not wrong to call the number that. But you may also know that it's 9,812,345, and it's a mixed number. It's a big mixed number, except the part of the number that's less than 1 is in decimal form rather than fraction form, but decimals really are fractions. And this part of the number to the right of the decimal point, well, 6789, it looks like 6,789, and that is the numerator of the fraction. When we say and, we'll say and 6,789 what's? Well, some of you know that you can name the places to the right of the decimal point in a certain order beginning with tenths. And to the right of the decimal point, all the place names end in THS. So we have tenths, hundredths, thousandths, and 10,000ths. So we can name this number as 9,812,345 and 6,789 10,000ths. So the fraction part of it could be written like that. So now we can express this rather big number as a mixed number. Those two numbers are exactly the same. And again, the place values go tenths, hundredths, thousandths, 10,000ths. The next one here, if we had it, would be 100,000ths, and then millionths. It sort of mirrors what's happening the other way to the left of the decimal point, except with the THS at the end. And you start here to the right of the decimal point with tenths. There's no such thing as oneths. If you want to think of there being oneths, well, think of it this way. It's the same as the ones, okay? Now, I think you all know this. You probably started learning this perhaps in third grade. But what I want to now present to you is a simple way to convert any decimal number into a fraction. It's what I like to call a mechanical process. There's really not much thinking to it. And the key to this is to realize that any decimal number is a fraction with a denominator that is a power of 10. Now, we studied powers or exponents, right? 10 to the 1 power is 10. 10 to the 2 power is 10 times 10, or 100. 10 to the 3rd power is 10 times 10 times 10, or 1,000. 10 to the 4th power is 4 tens multiplied together. And if you think about that, multiplying 4 tens together is going to be a 1 followed by 4 zeros. You should be detecting a pattern here. The exponent on the power of 10 will be the same as the number of zeros following the 1. And that's important to recall. The exponent on the power of 10 is not how many digits there are, but it's how many zeros there are after the 1. Okay? Now, why am I talking about these powers of 10? Because they are the denominators of a decimal fraction. And if we look back at this number that we started with here, the first way that I converted into a mixed number, with a fraction rather than a decimal, was to identify the place values, and the 9, the last digit, is in the 10,000ths place, so that became the denominator. And that works. But here's something else that works. Just look at this part of the number. Okay? Over here, obviously, is the whole number part. What we can do is we can say, okay, those digits to the right of the decimal point are going to be the numerator. 6, 7, 8, 9. And what's the denominator? It's a 1 followed by 4 zeros. Now that's 10,000, and the 9 is in the 10,000ths place. But notice there are 4 digits to the right of the decimal point. This is the key to the link between decimal numbers and fractions. The numerator will be the digits you see there. The denominator will be a 1 followed by however many, the same number of zeros as there are digits to the right of the decimal point. It's wordy to say it, but it's a really simple concept. You put a 1 here, and then you count, there are 4 digits to the right of the decimal point. So you put 4 zeros, 1, 2, 3, 4, corresponding with the 4 digits to the right of the decimal point. And the big mistake that people sometimes make here is to count the digits rather than the zeros. Don't count the 1. There are 4 places, 4 digits to the right of the decimal point. They correspond with the 4 zeros. Okay? This is a review. I've already taught you this. Now, this idea of representing a decimal number as a fraction, if the decimal number is greater than 1, you have a couple of choices. First thing you could do here is see this in 2 pieces, the whole number part and the and the part that's less than 1. So you could say that this is 3 and then you focus to the right of the decimal point, you see a 5, so that's the numerator, and there's 1 digit to the right of the decimal point. So the denominator is a 1 followed by 1 0. And of course, this simplifies to 3.5. We all know that 3.5 is the same as 3.5. We divide the top and bottom here by 5 to get the half. I want to take this opportunity to remind you of why, when we have a decimal number with digits to the right of the decimal point, we can always tack on a 0 to the end and not change the number. It'll still be the same number. We can tack on as many zeros as we want. Let's take a look at why. 3.50. Let's take the same approach as we did up there and say that it's 3 and, now that looks like 50, so that'll be the numerator, and then the denominator will be a 1 followed by 2 zeros, right? 3 and 50/100ths. Well, of course, that also simplifies to 3 1/2 if we divide the top and bottom by 50. Now, it's probably better for me to have done this. 3.5 equals 3 5/10. So now let's multiply the top and bottom of the fraction by 10 and get 3 50/100ths. And then we can just work backwards to realize that 3 and 50 hundredths is 3 point, and then whatever digits are in the numerator, and we have to have 2 digits to the right of the decimal point because of the 2 zeros, so we write it as 3.50. In other words, the reason we can tack on zeros to the end of decimal numbers is because of equivalent fractions, because we multiplied the top and bottom of the 5/10 here by 10, and we know that when we do that, we get an equivalent fraction. This 50 hundredths is the same as the 5/10. So everything relates, and really, in studying decimals, it's important to realize that they are fractions, and all the rules that you have for fractions apply to decimals as well. What if we have the decimal 0.125? Now that's less than 1. By tradition, we sometimes put a 0 there, just to sort of alert us to the fact that there's a decimal point here, make sure our eye doesn't see this as the whole number 125. So there could be a 0 there. It's optional though, you don't really need it. We look at the number, a decimal number, whether it's greater than 1 or less than 1, and the digits that we see become the numerator. So the numerator is 125. What's the denominator? Well, we look and see that we have 3 digits to the right of the decimal point, 1, 2, 3. So we put a 1 here, and then 3 zeros. So the way we can put this, the lights went out. the way we can put this into a fraction form is automatic. It's a mechanical process involving counting. Might as well point out that if we were to divide the top and bottom of this fraction by 125, you may not recognize that 1,000 divided by 125 is 8, but it is. So this fraction simplifies all the way down to 1/8. All right. What if we had, let's say, 0.03? Well, we look at the digits, and whatever digits we see become the numerator as a whole number. You know, fractions are made up of whole numbers, top and bottom. Later, you'll see that they can be integers. They could be negative and perhaps get a negative number as a result. You can have non-whole numbers in fractions. They're known as complex fractions, and that'll be a part of 6th grade math, coming to terms with something like 2.5 fifths. Now, young people don't study 2.5 fifths. It's not anything they're presented with ever. You may use your understanding of numbers, your number sense, to realize that's a half. We can simplify this complex fraction to 1/2. Multiply the top and bottom by 2, let's say, and get 5/10, and then the 5/10 simplifies to 1/2. Or you can simply realize 2.5 is half of 5. That works as well. Complex fractions will be part of our 6th grade math study, but we won't get into them anymore today. So 0.3 as a whole number is the same as 3. This may be something you never really thought of before, but there's the whole number 3. If we put a 0 in front of it without any decimal point, it's still 3. It's 0 tens and 3 ones. We can put another 0 here, and it's 0 hundreds and 0 tens and 3 ones. We almost never see that, but in this case, it's important to realize that, you know, taking the digits that you see and making them the numerator as a whole number, more likely we'll just write it as 3. Okay. Now, what's the denominator? Well, the denominator, this is a decimal number, so the denominator will start with 1 and have zeros. How many zeros? 1, 2, 1, 2. See how simple it is? So 0.03 is 300. Now, could you have gotten to the same result by saying, hey, this is the 10th place, this is the 100th place? So the denominator will be whatever that last place is on the right. Will that work? Yes, it does. But I think this way of just, you know, counting the digits to the right of the decimal point, matching that up with the number of zeros in the denominator is easier. It's mechanical. I just want to make this final point. A lot of you probably recognize this number if you had to read it without using the word point. It's okay to use the word point, 12.037, but it's also 12 and 37 thousandths. So you can sort of break it apart, like I said before, and say, okay, it's 12, the whole number 12, and then 1, 2, 3 digits to the right of the decimal point. So the denominator is 1,000, 1, 2, 3 zeros. The numerator, once again, the digits here, 0, 3, 7, if we write that as a whole number, it's 37. And you don't need that 0 in front. Probably wise not to put it there because you could confuse people. All right, so this is 12 and 37 thousandths. But here's another option. You could look at the number as a whole and see the digits. The digits are 1, 2, 0, 3, 7. Make that the whole number of your, write that as a whole number without the decimal point. That becomes the numerator of your fraction. The denominator is still 1,000 because in determining the denominator of a decimal number, you look at how many digits there are to the right of the decimal point. You see the 3, so you put a 1 and the 3 zeros. So what is the difference between these two? Well, they are the same number. Okay, all 3 of the numbers that I've written up there are the same. And you have some math vocabulary at this point to be able to say, all right, this thing here is an improper fraction. It's greater than 1. It's certainly greater than 1. And you know how to represent improper fractions as mixed numbers. Isn't it that? Isn't this improper fraction written as a mixed number? 12 and 37 thousandths. You should be able to sort of recognize that mentally, but if you really wanted to show why, you could say this improper fraction is 12,000 thousandths, right, plus 37 thousandths. If we had to add these two fractions, 12,000 plus 37 is 12,037 over the 1,000. But the 12,000 over 1,000, think about it, 12,000 divided by 1,000 is 12. So that becomes the 12, and then along with the 37 thousandths. So a little review of what I've taught you already about how easy and automatic it is to take any so-called decimal number and write it as a fraction. Decimals are fractions. That is a very important point. I mentioned earlier that there'll be 3 installments of the summer work in terms of videos and some work to go along with them. I don't intend the work to be time-consuming. The approach that I would like you to take with these summer assignments is I would like you to think of quality versus quantity. Make the time that you spend watching the videos and working out the problems, make it quality. It shouldn't be very time-consuming, and that might depend on the individual. I would urge you, if necessary, to rewatch some of the videos. Maybe you run into problems when you're trying to work something out. You can go back and rewatch the video. So we're not looking to have a lot of your wonderful summer time taken up with this, but some quality work now can pay dividends down the road. Another thing about making these videos, I've kind of taken the approach that I don't want them to be too long. When I generally get up to 20 minutes or so, I think about wrapping up, and I see that we're over 19 minutes now. So this first installment, first of 3 installments during the summer, I'm going to break this into multiple videos. The first one that we just did is about what is a decimal number, the definition of a decimal number, and how do you easily convert from a decimal to a fraction. And I'm not sure how many more there'll be for this first installment, whether there'll be 1 more or 2 more, but in those next ones, I'm going to work on the calculations with decimals. Maybe it would make sense to have 3 and do addition and subtraction, and then multiplication and division. So 3 videos, but combined, they shouldn't be terribly time consuming. Always work toward understanding. That is the key. You, in the course of your math journeys, you are writing the story for yourself with my guidance. Math is a story, and it should all make sense. I'm always willing to help you along that journey. I'm happy to correspond during the summer by email and guide you on your journey. But ultimately, it is you who will make the math make sense for yourself. So I'll see you in the next part of the first summer videos and assignments. Bye-bye for now.